Welcome friends, let's check whether y equals a plus b times e to the x solves this differential equation. So differentiate. So y prime first. Well, that would be just the derivative with respect to x of a plus be raised to the x. But when you differentiate that, the only thing left over is be raised to the x because a is constant and goes away. The derivative of e to the x is e to the x, and the b is just a constant. Form y double prime, so that would be just the derivative with respect to x of be raised to the x, which is then just raised to the x, because b is constant, e to the x is e to the x. So now you plug it in and see whether you get a 0 on the left side or not. So be raised to the x minus be raised to the x. We're asking, in other words, is this equal to 0? We're not saying it is, we're asking. So 0 is certainly equal to 0, isn't it? So notice it doesn't matter what the value of b is. If b is 2, then it's 2e to the x minus 2e to the x is 0, you see, and so on. So let's apply some initial conditions. Let's say we want y prime of 0 to be equal to some number like 1, and then let's say y of 0. Let's say we want that to be equal to a number like 1 also. I'll make it 2, just for the sake of variety. Let's see what happens in this case. Then let's apply the first condition, so it's going to be y prime of 0 equals 1. So x is 0, that's what it's telling us, and y prime of 0 of that x, right? So y prime, we want that to be equal to positive 1 at that point. So you plug it into the following. You have to use, in other words, y prime equals be raised to the x. You have to use that. Then you replace 1 is equal to b e to the 0 like this. E to the 0 is 1, so you have 1 is equal to b. Then you have to use the other one. So when you say y of 0 equals 2, that's like saying we have the point 0 comma 2, in other words. All right, this is your value of x, and this is your value of y over here. So then you plug this in, so you're going to have 2 is equal to, so a is the quantity to be found plus b, but b is 1, and then e, and then x is 0 to the 0, like this. So you have 2 is equal to a plus 1. Yep, so it looks as though you'd have 2 minus 1 as the value of a, so a is equal to 1. Therefore, we end up with a specific function y of x is equal to 1 plus e to the x. Well, let's graph this, see whether this makes sense or not. We should always do that just as a confirmation, especially when it's easy with software, right? So when we do that here, we will have 1 plus e to the x, so that's the solution. So notice something. When 0 goes in, 2 comes out, so that part is matched, right? Because I imposed the condition when 0 goes in, I want 2 to come out. That's good. When you differentiate 1 plus e to the x is just e to the x. That is the first derivative. And notice when 0 goes in, 1 comes out. So that condition is also matched. Remember that this equation that matches these specific conditions on the first derivative and the function, that also, again, solves the original equation. So you can always check that if you want. But that would be, the second derivative would be the following, right? So 1 plus e to the x, differentiated once is e to the x, like this. And then when you differentiate again, e to the x, you get e to the x, you see? So you just end up with e to the x minus y prime, which is e to the x. You're checking, does this equal to 0? Yeah, well, that's definitely 0 is equal to 0, like this, right? This is true. So leave a like if it's helpful. Thank you. I'll see you in another video.